Alright, in this video we're going to do MassPercent, which is trying to find out the concentration of a solute within a solution. So this is just one of many ways you can represent the concentration of a solute within a solution. We're using MassPercent because it's hopefully something we're familiar with dealing with percentage. Now, another way to write percentage, and you may hear me refer to this, is parts per hundred, or pph. Okay, and that's pretty much what we get when we break down the word percent, right? We have per cent, cent meaning hundred, such as century being 100 years. Okay, so we're talking about parts per hundred. Now the equation is pretty easy, right? You get the mass of the solute, whatever that mass may be, and you divide it by the mass of the solution. Now here's the tricky part. The solution, right, consists of the mass of solute plus the mass of the solvent. Okay, so we're actually going to have to do a little addition problem in before we actually do the overall calculation, which that in and of itself is not done because it's a percentage. So we'll have to take this quotient and then multiply it by 100 to get the mass percent. Okay, so or parts per hundred. So let's go ahead and do an example problem. Okay, so if I have 1.00 grams of ethanol in 100 grams, 100.0 grams of water, what is going to be the pph, or the parts per hundred, or mass percent? So let's go ahead and take a look and set up a problem, right? We have mass of solute over mass solution. Okay, well, again, mass of solution is the mass of the solute plus the solvent. So in this case, it would be the mass of solute over mass solute plus mass solvent. Okay, breaking that down. So mass of the solute in this case is 1.00 grams, and I'm going to divide that by the addition of 1.00 with 100.0. Okay, and my answer here, for at least the intermediate step, 1.00 grams. Okay, or I can lose the you can lose the gram, not that big a deal for this, and then I'll have 101.0. Remember, I need to maintain my sig figs. I have two digits after the decimal. I have one digit after the decimal, so I need to have only one digit after the decimal. Okay, so I'm going to take 1 divided by 101.0 and then multiply that by 100. So doing that, I'm going to have 3 sig figs in my answer, right? I'm going to multiply this by 100. That's all said and done. I do not need to use only one sig fig right there. My sig figs are going to be counted in this division problem. So I have 3 sig figs divided by 4 sig figs. So my final answer is going to end up being 0.990%. Okay, so if I have a gram of ethanol and 100 grams of water, my percentage is 0.99% ethanol. And it's important to write down what is it the percentage of, because I may give you more than one solute dissolved in the solution, and you'll have to identify which solute is which percentage. All right, so here's a different type of problem, but we're still going to be using the same equation. Okay, now on the previous problem we were solving for the percent or the percent mass, or the mass percent, or parts per hundred. Now I'm going to be solving for the mass of the solute. Okay, so here I have 175 gram sample of milk, which in this case milk is a solution, and it contains 4.5% lactose by mass. So I want to know how much lactose is in that 175 gram sample of milk. So looking here, I'm going to go mass of solute divided by mass of solution. Now the solution is the milk, right? And I multiply this by 100, 100, and I'm going to get the percentage. Well, in this case, um, I have this, obviously, because that's what parts per hundred is, and I have the mass of solution. I'm trying to solve for the mass of the solid. So I will rearrange this, and we'll go mass solute divided by mass solution is equal to, okay, the percentage divided by 100, right? Because if I divided both both this side over here and this side here by 100, I would get this, right? Well, again, if I just check off what I have, right? I have the mass of solution. Here's my x. I have my percentage, and I have 100. So then it just becomes a cross multiplication. Okay? So let's go ahead and do that. Fix these guys here. So I'm going to have mass of the solute, which is x, and I'm going to divide that by 175 because that's the mass of the solution, equals the percentage 4.5 divided by 100. Okay? Now, you can choose to, multiply reciprocals and stuff like that to isolate your variable. It's just easier for me, and it's easier for a lot of people, and fewer mistakes happen if you just do a cross multiplication. Right, so I'm going to end up with 100x is equal to 4.5 times 75. And remember to include our sig figs here. So with 2 sig figs in my answer, I'm going to end up with 790 because it was 787.5, but I only need 2 sig figs. Then I divide both sides by 100. Remember, this 100 right here is a factor. Okay, so it's not going to play any part in our sig figs. So my final answer should still have 2 sig figs. So my final answer is 7.9 grams. And the reason why I know it's grams is because I want to know the mass of the lactose. So to sum it up, if I had a 175 gram sample of milk and 4.5% of it is lactose, then I know that there is 7.9 grams of lactose in that 175 grams of milk. Tomorrow we will have a short quiz on not just the contents of this video, but also the ability for you to read a solubility curve. Right? So if you guys have any questions, you can email me or let me know before class.